Many people still try to learn SQL the old way, watching endless tutorials or trying to memorize syntax like it's 2010. But in 2025, that strategy will cost you time, money, and momentum. Today, tools like ChatGPT can write most SQL queries for you, so your job isn't to memorize syntax. Your job is to know what to ask, why it works, and how to structure your data to get the results you need, or gain insights that shape your database design. In the next 10 minutes, I'll show you a smarter and faster way to learn SQL, one that leverages AI while helping you truly understand what's happening under the hood. First, what not to do. A lot of people begin their SQL journey with this pattern. Learn select, then where, then join, then just keep practicing until it sticks. You'll watch tutorial after tutorial that walks through query after query, showing the same surface level pattern, but never really explaining what's going on underneath. They might teach you how to join two tables, but not how the join works and what an Cartesian product is. They'll show you the syntax for where, but skips over how the database engine actually processes that filter. This is like learning to recite a song in a foreign language without knowing the meanings of any words. Here's the problem with this approach. You don't build real understanding, and you may get stuck the moment your task becomes even a little bit complex. And this approach of learning will set you up for directly competing with AI, and you know that you will lose even now, let alone in a few years. So what to do instead? We wanted to highlight at least two things that you should consider doing. First, you want to go beyond a simple SQL syntax to learn how to design smart questions that can be translated to SQL queries by generative AI. Different from most programming languages like Java or Python, SQL is declarative. By saying that, I mean SQL is more aligned with natural languages. When you deal with SQL, you only need to describe what results you want, not how to compute it step by step. This makes it exceptionally well suited for AI tools like ChatGPT or Copilot for various reasons, such as that SQL has a limited and consistent structure, and there's no control flow or state tracking in SQL. AI can generate correct or even optimized queries with just a plain English prompt now. So in most cases, you don't need to write the syntax by hand. You can delegate that part. The more important skill is shifting your role. The new challenge isn't how do I write this query. It is instead what exactly am I trying to find out from the data. That sounds simple, but it's actually a higher order thinking skill. AI can't offer much help if you don't know what you are looking for. Learning SQL today means learning how to translate your real-world questions into something a database can understand. To do that well, you need to know the language of data. You need to understand what a table is, how relationships between entities work, how joins work, and how your data is structured. Sometimes you even need some domain knowledge, like what active users mean in a marketing context, or what a transaction is in a financial dataset. So yes, you are offloading the mechanics, but you are upgrading the strategy. And here's the best part. Once you get good at designing smart questions in SQL, you'll get better at asking the right business questions, designing dashboard, exploring data, or even writing better prompts for other AI tools. You are not just learning SQL. You are learning to think clearly about data, and that's a competitive edge across different fields. Second, you should focus on why and how behind and beyond SQL queries. One of the most underrated ways to learn SQL, especially today, is to learn it in context. Think of learning SQL like learning a new language. Sure, you could memorize vocabulary lists and grammar rules, but you will learn faster and retain more if you're actually using it in an authentic activity, like reading or conversation. The same applies to SQL. Instead of keeping practicing isolated queries, you need to connect SQL to real tasks that matter to you. That's how you start uncovering the why and how behind each line of SQL that you write. If you are aiming to become a software engineer, a great entry point is to learn database design. Why? Because when you learn database design, you are forced to think about what data types to use, how tables relate to each other, and how to structure the data for future queries and applications. Take a simple example. Suppose you decide between using datetime and a timestamp for a column. At the first glance, they may seem interchangeable, but datetime just stores the date and time as it is, whereas timestamp is stored in Coordinated Universal Time, short for UTC. A time stored in this format can be automatically adjusted for time zones when the data is read. If you're building a global app, this seemingly small choice can lead to big problems or save you from one. These kind of details, the ones that you don't see in most tutorials, are exactly what you better at SQL in the long run. If you're on the data analytics path, your best teacher is real data, an actual realistic and possibly messy dataset from an actual relational database. Try using the data to build a dashboard, generating reports, or answering real business questions. Here's what I mean. Instead of learning group by in isolation, try calculating weekly retention from actual event data. Instead of just filtering rows, try preparing selected product data for a sales dashboard. Instead of writing a drawing just because your course told you so, try explaining user conversion rates across different sign-up flows. This way, you are not just asking how do I write this query. You are asking what does the metric mean? What shape does my data need to be in? Or how can I make this accurate and useful? The bottom line is this. You will learn SQL more deeply if you stop treating it like the end goal. Use it to design and implement databases. Use it to answer better questions. That's how you will get good, and that's how you will stay ahead, especially now AI can write nearly all the queries for you. Now you know what not to do and what to do to speed up your mastery of SQL. Let me introduce a learning roadmap that encapsulates these ideas. A smart learning roadmap still starts with mastery of the fundamentals. By saying that, I mean you still need to learn how to write SQL like select, from, and where clauses. But don't stop there, and don't drown yourself with similar SQL practices. Instead, what really separates effective learners from those who get stuck is this. The effective learners understand the relational model that SQL is built on. For example, understanding what a table really is, not just a spreadsheet of data, but a set of tuples that follows a schema, changes how you think about joins, keys, and constraints. For another example, the understanding of foreign keys shouldn't just be limited to their technical details. Foreign keys define relationships between entities and shape how you design your queries and your database. A lot of people know the syntax of join clauses, but they can't tell you how the difference in cardinalities impact how you write the join queries. Another key idea is set-based thinking. SQL operates on sets, not rows. That's why functions like count, group by, and distinct behave the way they do, and why you can't always think procedurally. These concepts may sound academic, but they are exactly what gives you confidence when reading, modifying, or validating AI-generated queries. So yes, learn your syntax, but if you want to learn SQL faster and retain it longer, focus on the core ideas behind it. Understanding the relational model is more important than memorizing syntax, and that foundation will pay off again and again as your projects grow more complex. If you want to get really good at SQL, you need to go beyond just writing queries, and what that means depends on what you are learning SQL for. If you are on the path of software engineering, learn SQL in isolation is like learning vocabulary without knowing how sentences are structured. You need to understand how databases are designed, because design decisions directly impact how queries work. For example, after learning various aspects of database security, you will know that password encryption only demands increasing the varchar size of the password column, but not necessarily the data type, because one-way hashed passwords require a bigger data storage, but can comfortably stay as characters. Such a change is critical, yet may seem so trivial and ridiculous in the eyes of those who limit their learning to just SQL itself. So if you're aiming to become a software engineer, go deeper into database design. This is where serious matter, not in a purely academic way, but in a way that changes how you build software systems. If you are serious about this path, I have some resources to recommend. The Book of Database System Concepts, a time-tested academic classic, which is in its 7th edition now. If you want an easier entry into this topic, grokking relational database design could be a choice. It's a modern example-driven approach that works for self-learners and developers. As a disclaimer, I'm the lead author of this book. However, if you're learning SQL for data analytics, your learning journey should focus on how SQL fits into the larger data analytics pipeline. SQL is a tool that you use to ask questions from real data, but what makes those questions meaningful is the context of your analysis task. For example, instead of learning group by in the abstract, it will be more productive if you try to analyze user behavior from a website log, or track sales performance over time, or segment customers by purchase pattern. These aren't just exercise. They teach you why you need certain joins or filters, and how to structure queries for insights, not just for correctness. Taking on projects like building a dashboard or generating a weekly report for stakeholders gives you a reason to apply window function, nested queries, all in a real-world context. In addition to that, you will be naturally exposed to related tools like Excel, Power BI, or Looker Studio, or even Python libraries like Pandas or SQL Alchemy, or data cleaning and transformation steps that complement SQL. A great way to accelerate this kind of learning is to pick up datasets that you care about, public dataset, sport dataset, financial dataset, or anything, and challenge yourself to tell a story with it using SQL. So whether you're building an analysis pipeline or telling a data-driven story, going beyond queries means understanding how SQL fits into the bigger picture of the problem you are solving. Once you have built the foundations and gone beyond just the queries, the best way to level up is by working on real projects. Projects that give you a context, purpose, and clear goals. They connect everything you have learned. If you are learning for software engineering, start building databases from scratch. Such activities will force you to think about data integrity, normalization, and how your schema decisions affect how SQL behaves. As I record this video, I realize that authentic problems on database designs are scattered and their qualities are uneven. So, I'm currently working on a public GitHub repo to aggregate quality problem sets on database design and implementation. The URL of this repo is here. You can find the link to this repo in the description of this video as well. Remember that you don't need a perfect idea or a big plan. The key is to start doing something small, messy, and real. That's where the real learning happens. That's how you go from a student to an expert. If you are learning for data analytics, then your focus should be on querying, analyzing, and communicating insights. Pick a public dataset from Kaggle, Google Dataset Search, or data.gov. Import it into a database system. Start with simple questions like what are the top 5 cities by population growth, which product category has the highest return rate, or how has revenue changed month over month. Then go deeper. Group by, filter, join with another table, and try visualizing your results. Try to answer a real question as if you were building a report for a stakeholder. And again, write up your analysis, push your queries and charts to GitHub, share your data analysis on Kaggle. This gives your learning a purpose, and it builds a public track record of your growth. In this video, we explored how to learn SQL deeper and better. Such a discussion becomes unavoidable when generative AI tools can write accurate and even optimized SQL queries given a proper prompt. If you find this video helpful, give it a thumb up, subscribe, and drop your questions in the comments. I would love to hear from what's working for you and what needs to change.